one pair of parallel lines. Here we have parallel lines A and B, cut by a transversal, that is any line that intersects any two or more other lines, creates a really interesting dynamic. So take a look right here. This group of angles, each one marked with its angle measure, and I'm going to go ahead and use options. As soon as I can get to my options bar here. To round to 0 decimal places. Okay, so now it's clear that I have a 100-degree angle and an 80-degree angle, and another 100-degree angle and an 80-degree angle. These pairs are supplementary, and these pairs are supplementary. Because the measure of this angle didn't change, it is clear that vertical angles will always be congruent. Now this pair is also supplementary to this pair, and because these two 80-degree angles didn't change, these two will always be congruent. So vertical angles are congruent. This is a fact we can rely on. So take a look at this text box. We have parallel lines A and B. These lines are parallel. I created them with the parallel line tool. This is the only relationship between lines that allows for translation symmetry to show this particular set of congruent angle pairs. So let's use the snipping tool to take a screenshot of this group right here. And let's see if we can use the copy tool. I do not want to save the changes, but I wonder if it will let me actually insert from the clipboard. Let's see. Okay. I got an idea. Let's use the image tool to insert an image here that I have saved on my desktop, and it's called Hello Vertical Angles. Now, will the move tool allow me to take this image, I hope it does, and move it? It won't. So I'm going to remove it, and I inserted it here, and I believe that's where the lower left corner of the image landed. So I'm going to put it down here a little bit. Image, insert, hello vertical angles. It's close-ish. And I wonder if moving this point, there's a great idea. Let's move this point. Oh yes, that's perfect. Okay, check it out. When I have a pair of parallel lines, I can translate an image along a directed vector, and that vector is here. Moves from I to J. See it? I can translate that image along IJ, and it will land, it will map onto the congruent angles at the other intersection. How fabulous is that? I'm really impressed with this transversal. So now we have to figure out how to name this relationship, and this green angle corresponds with this green angle. So we're going to call this relationship, wait for it, Where's my text box tool? This relationship is called corresponding. And the formal definition for this phenomenon that we're seeing is when two parallel, and that's the important part here, when two parallel lines are cut by a transversal, corresponding angles are congruent. This is because there is a rigid transformation that maps one angle onto the next. And that rigid transformation is what? A translation. That is so cool. It's so cool that it deserves a better color. It deserves a larger text. Okay, that's maybe too large. Ooh, it deserves italicizing. It deserves bolding. And maybe it even deserves serif. When two parallel lines are cut by a transversal, corresponding angles are congruent. This is because there is a rigid transformation that maps one angle onto the next. Oh, I'd better edit this right here. Cool. So I'm going to turn this line off just for the heck of it. And I'm going to put another line in, and I want it to be a line we can change. So I'd like to use just the regular old line tool, and I'd like to put it through these 2 points. At the moment, lines A and E are parallel, but what happens as soon as I change that? As soon as the lines are no longer parallel, it's still a transversal because it's still intersecting 2 or more lines, but the angles aren't the same anymore because there is not a rigid transformation that maps one group of angles onto the next unless this line is locked in parallel step with the other. Okay? So, lines, the relationship changes as the relationship of the lines change. So the important part here is that the lines must be parallel.
Mm-hmm.